Welcome to section 8.1, multiplying and dividing rational expressions. Before we get into the multiplication and division of rational expressions, we first must cover the factoring component because majority will involve a lot of factoring, and if you're not familiar with that, it's going to be a bit difficult to work with multiplication and division with rational expressions. So we have worked where we were foiling, which involved a lot of multiplication. When we talk about factoring, it's the opposite of FOIL, meaning the opposite operation. Therefore, when it comes to factoring, you're going to have a lot of dividing components. So let's take a look at the first example, 12x minus 36. Now, most would think about the common factor between these two terms. So let me underline these two terms. Now, some would probably say that 2 would be involved because they're both even numbers. So if we divide both factors by the common factor, which is the 2, then our common factor will be outside the parenthesis. And then we do 12x divided by 2, which is 6x. And then we do negative 36 divided by 2, which is minus 18. Now the issue here is that we're not finished, because if you look inside the parenthesis, 6x minus 18, there's another factor that's involved. Now some might say 3, or some might say 6, but let's try with 6. So the common factor inside the parenthesis is the 6, and again, our common factor would be outside the parenthesis. 6x divided by 6 is x, minus 18 divided by 6 will be minus 3, and you still have the 2 that's outside, don't forget that. Any number you bring outside the parenthesis will be multiplying. So here we have 2 times 6, which is 12. And then the factor that's inside the parenthesis will stay the same. So notice how we have a 12 outside, and if you look closely, a 12 can go to 12x and negative 36 from the very beginning. So what we could have done at the very beginning for 12x minus 36, when we were factoring into GCF, greatest common factor. So let me label that out first. We're doing GCF, greatest common factor, meaning what's in common in each term. So when we factor, we could have factored out 12 because 12 can go into 12x and 12 can go into negative 36. My GCF will be outside the parenthesis. So 12x divided by 12 will be x. Negative 36 divided by 12 will be minus 3. So we got the same answer. It's just that if you are going to start with smaller numbers, which is okay, you just got to know that you're going to be doing multiple steps. So here, if you double check what's inside your parenthesis, if you have a common factor, you got to keep going. And any other common factor that you factor out, you have to multiply to the number that's already outside the parenthesis. If you don't do that, then you will get the wrong answer, or it will be incomplete. So if you can find a common factor that's higher than 2 or 6, then go with it. It'll be less work. If not, then you do multiple steps. You just gotta make sure to double check if there's any common factor in between. If there is, you keep going. If not, it will be incomplete and you will have the wrong answer. But for this example, our final answer is 12 times x minus 3. In this example, we have negative 9x plus 15y. So when we're doing the GCF, factor by GCF, meaning you're looking for the greatest common factor, let's find what's in common with these two terms. So we have negative 9 and 15. Both of these numbers are divisible by 3. Now, when we're doing GCF, we have to check on the first term, which is negative 9x. If it's negative, if the first term is negative, that means that we're going to divide both terms by negative factor. So in this example, we're going to divide both terms by negative 3. So my greatest common factor, negative 3, will be on the outside. Negative 9x divided by negative 3 will be positive 3x. Positive 15y divided by negative 3 will be negative 5y or minus 5y. And double check, there's nothing in common between 3x and negative 5y, so I have finished factoring by GCF. Therefore, this is my final answer. In this example, we have negative 20x to the fifth minus 4x squared, or 4x to the second power. So let's start factoring by our GCF. So we have two terms, negative 20x to the fifth and negative 4x to the second power. So we have a negative 20 and a negative 4. Both of these numbers are divisible by 4. And then double checking the first term, we see that the first term is negative, so we're going to divide by a negative 4, not a positive 4. What else is in common between these two terms are the x's, so let me write the x. Now, notice how they have exponents on both of these x to the fifth and x squared. So in the event we're doing factoring by GCF, we usually go with the lowest exponent. So we're going to divide by x squared or x to the second power. So when we're dividing, our GCF will be outside of parentheses, so negative 4x squared. So negative 20 divided by negative 4 will be a positive 5. Now when we're dividing with the same variable, we're going to subtract the exponent just like how we did in chapter 5, but we're going to start with 5 minus bottom. So 5 minus 2 is just 3. Then over here, negative 4 divided by negative 4 is just positive 1. So we're just going to focus on the x. So x squared divided by x squared. So when we subtract, it's 2 minus 2, which is 0. That means it's going to be 1. So let's look at the whole fraction. When it's a negative 4x squared divided by a negative 4x squared, we know that the numerator is the same as the denominator. So negative divided by negative, it will also become positive 1. So that's my factor, and then double checking, there's nothing in common between 5x to the third and 1, except the only number is 1, but we don't need to do that. So here's my final answer, and let me box that up. Now to review with this example, we not only divide by a common number, but also a common variable, which is the x. But we also have the square on the x because the first term has x to the fifth and the second term has x to the second power. The reason we went to the second power is because x squared can go into x to the fifth, whereas over here in the second term, at most, is x squared. So that's why we use the common factor. In the common factor, the x squared. So at most, in both terms, x squared can go into both these terms. We can't use x to the fifth because x to the fifth is higher than the second term, and when you're dividing, it won't go into it. We're just going to end up with a negative number, and we're still going to have x, but we've got to keep factoring. So you want to use the right factors with the right exponent so that you don't make mistakes of having negative exponents. That means you got to keep going. When you have negative exponents, you're going to have fractions. So that could be problematic, and you end up doing more steps. So when you're dividing with common variable, go with the lowest exponent. The lowest exponent.